All right, this is Mr. J's Chemistry, and we're going to go through some math here today. Significant figures. Looks like the first part of this is determining the number of significant figures in the following values. So we're going to use these as notes, but I'm also going to give you some rules along the way, and I'll make sure that you have those rules on paper before we have any quizzes. So let's go through some of these. I'm not doing all of it, but I'm going to give you a good portion of it. So let's look at number one here. And we want to look at the number of significant figures in the number 140.74. Being that there's a decimal there, every digit is significant, so there are 5 sig figs there. With the second one, 0.0041, those are leading zeros. Leading zeros are not significant. Okay? So these aren't going to count. So there's only 2 sig figs there. In the number 31, those are trailing zeros. These zeros right here, those are called trailing zeros. They do count as sig figs. So we have 4 total sig figs in that one. In the number 1,300, there are only 2 sig figs. The reason why? There is no decimal. So those zeros, those trailing zeros, do not count. We have the number 847.040. Every single digit here counts. That decimal is there. Each zero counts. That's a trailing zero right here. This zero is between 2 non-zero numbers. So we have 6 sig figs. The number 4 stands by itself, 1 sig fig. In scientific notation, we don't look at anything but the numbers in front of the multiplication symbol. So any of this stuff right here, we don't even need to look at. So in the number 3.70, that 0 does count because there is a decimal right there. So there are 3. 1.05, there's a decimal. That's 3 sig figs. 7.0440. Oh, hold on. 7.0400. These zeros are trailing zeros. They count. That 0 counts. We got a decimal there. So there are a total of 5. The number 2,495. All numbers count. They're all sig figs. There are 4. So sig figs are numbers that have value in a measurement. All of those numbers that I counted today have value, except some certain ones I didn't. So now we're going to round to 3 sig figs. So now we're going to round to 3 sig figs for this number. Here's 3 digits. Okay, that's 3 sig figs. You look to the number to the right, and that 4 does not round that 6 up, so our number is going to be 3.76. These are 3 significant digits. We look to the 8. The 8 will round the 6 up to a 7, so my number is 3.77. We use these 3 digits for sig figs. Those are the 3. The 5 will round the 6 up. Okay, that's all good. That's part of the rounding rules. So 3.77. 11.0. Those are the 3 significant figures we're going to be using. The 0 does count. The 4 does not round that 0 up, so we end up with 11.0. 8.75. The 5, this one to the right, rounds that 5 up to a 6. 8.76. Okay? All right. I'll do one more. We have 0.041. These are leading zeros here, and this 0 does not count, that 0 does not count, but this does count, okay? So we'll round that to 0.0412 because that 9 right here is going to round that 1 up to a 2. All right, well, I'm going to leave the remainder up to you, and we'll look at those answers later, okay? Okay, so now we're going to perform some other math. Performing the following calculations and round the final answer to the correct number of sig figs. In adding and subtracting, the rule is look at the number in the problem that has the least number of decimal places, okay? And that means to the right of the decimal. So in the problem, so if you look at it, there are 4 decimal places here, there are 3 decimal places here, and 4 decimal places here. And so if we do the math in this problem using our calculator, we'll find out that our answer must have 3 decimal places, okay? So let me get my handy-dandy calculator out. So let me log into my phone here. And here we go. 18.7644 minus 3.472 plus 0.4101. The answer comes out to be, for that problem, 15.7025. But since we're looking for only 3 significant digits, or 3 digits past the decimal, that means to the right of the decimal, our answer is going to change. So the 5, we're going to need these right here. But that 5 is going to round that 2 up to a 3. So my answer now becomes 15.703. Okay. Here's a division problem right here. 17.441 divided by 3. Well, in multiplying and division, you look to the number in the problem that has the least or the fewest significant figures. And that number would be this one right here, the 3. There is 1. So in our answer, you must have 1 sig fig. So 17.441 divided by 3, the answer comes out to be, well, we'll write it right here, 5.81 and other numbers besides that. We only need 1 sig fig in the answer. So we're going to look to the left of the decimal. We see that 5 right there. But if we look to the right of that, we see an 8. That 8 is going to round that 5 up to a 6. So our answer is going to be 6. Okay? I'm going to leave it at that and let you work the remaining numbers, and we'll look at the answers later. Okay? Let's now go to the bottom. All right. So now we are converting the following into scientific notation, or getting it out of scientific notation and putting it into standard notation. Okay. Well, here we have the standard notation of the first one of 47,000. So the rule is I got to change the thickness of this pencil. See if I can do it. I'm not doing it. Come on. Cooperate. It's not cooperating. Okay. So 47,000. The rule is, first of all, the decimal in that number is right there. But you want the decimal in scientific notation to be between the first 2 non-zero digits, and that would be between the 4 and the 7, which is right there. So now we got to take our decimal, and for our new decimal, and count back to the old one to see how many spaces away that old one was. So let's count. 1, 2, 3, 4. Okay, that's 4 digits, right? So our notation goes like this. 4.7, because that's what we'll write, and then we write times 10, and we counted 4 spaces, so our exponent will be a 4. And so it's read 4.7 times 10 to the 4th power, okay? We're going to go the opposite direction. We have 0.0008. Well, that number is less than 1. That means if the value is less than 1, the exponent is negative, okay? Because we'll be counting to the left. When you count to the right, the exponent is positive. When you count to the left, the exponent is negative. All right, forget that. All right, so the decimals here all right, we want the decimal in scientific notation to go right there. We don't have to write it because it's just an 8. You can if you want. You wanted to write a 0, you can do that. So let's count backwards for our new decimal. Whoops. Let me get rid of that. It's a mess. Ooh, I'm having a problem today. Get rid of that. And there we go. All right. So 1, 2, 3, 4 spaces to the left. And so we'll write 8 times 10 to the minus 4 because we went to the left instead of going to the right. Okay, so I'm going to let you solve the next 3, and I'm going to move on to the bottom down here. Okay, so we have scientific notation here, 7.66 times 10 to the minus 2. All right, well, what we're going to do is we're going to rewrite our number, and we're going to put 7.66 right here, okay? And we're going to go 2 spaces to the left because we have that exponent of a minus 2. So from our decimal right here, let's go to the left 2 spaces. 1, 2, that's our new decimal, and fill in that space with a 0. So now our new number happens to be 0.0766. And that is 7.66 to the minus 2, and that makes, and the number in standard notation is 0.0766. Here we have 7.8 times 10 to the 5th. The exponent is a positive 5. That means we're going to be counting our decimal 5 spaces to the right. So let's go ahead and put down 7.8 over here for a second, and we're going to count 5 spaces to the right. So let's do that from our decimal. 1, 2, 3, 4, 5. We can put our new decimal down there and fill in every space with a 0, all right? So our new number happens to be 780,000, and that's how you write that, okay? And those remaining numbers, those scientific notation numbers will be for you to solve. All right, now we're getting into metric conversions, and we got to show conversion factors. I haven't give you the conversion factors for all of these, so I'm going to give you those next. So we'll do this together in class. So once you get done solving the first side, we will look at the answers for it, and then we'll go and work on the second side. Within the metric system, we'll do that, and we'll do a little bit of English to metric conversions in class also. Okay? So I hope this helps. Good luck.